Hi, my name is Hamid Hussain, and in this video I will be showing you how to install and set up IsaacSim and IsaacLab on your Linux machine, specifically Ubuntu 22.04 given by the documentation. As I showed in the Windows installation, it is straightforward, but the documentation is not very intuitive. So I will still follow the official documentation throughout the process, but making it simpler and a step-by-step process. Okay, I will open the documentation. Make sure that you are on a stable version. We are using 5.1.0, and on the left hand side, going to quick install, you can see the download option. But I am going to go to download to make sure that I have the specific version installation, which is Linux x86-64. Now once you download this, you should have the downloaded folder as close to your root directory as possible. So in my case, I am downloading it in my home directory, and make sure you create a folder. In this case, I created IsaacSim as the folder. Inside that I have saved the file, and I have unzipped it. Now as per the system requirements goes, make sure that it meets your system requirements to show you if it is compatible with my system, or even for you to check it is compatible with your system. We can use a small script called isaac-sim compatibility checker. Now for Linux, what we are going to do is we are going to say that we will open this script using terminal. Mostly when we are working with Ubuntu or basically any Linux system, terminal is the most handy thing that we can have. So let me just ls see if I'm in the correct. I'm not, so I'm going to cd into isaac-sim folder. So isaac-sim, and if I press tab after writing 2-3 characters, it will autocomplete if it already exists in your list. If I write ls again I need to move into this folder, so I'm gonna say cd isaac and tab. I'm inside, and if I write ls, I should see isaac-sim compatibility checker. Now to run this, what we have to do is we have to write dot / and then write isaac-sim dot and then compatibility the compatibility check dot sh. If I press tab, it auto completes. Now if I run this, it should show me, so it's running in the terminal, and it should show me if it is compatible with my system. In this case, it is pretty much, although it's not very bright green, but it is a really good system that I have with me. So I have like 24 GBs of VRAM on my GPU, the NVIDIA L4 GPU. My driver version is also compatible. My CPU is also compatible, and my system RAM 64, although it's telling me that I should have had more, but it's enough for now, like for the beginner stage. It's making sure that I have the correct operating system, so in this case Ubuntu 22.04 LTS. This is my cloud setup. In my next video or in another video, I will show you how you can deploy a cloud instance, something similar to this, and you can have access to such powerful machine for on-demand use cases. Now that that's done, that's pretty much it. We just run another script. Let me just show you here to run the isaac-sim. Now we will face an issue. I will show you why and how to resolve that, but first let's just run this. Let me just clear, and if I write ls, I should run the selector just like we did in the Windows installation. So if I write dot / isaac-sim dot selector dot sh, it will give me an error and it will close. So it is giving me the selector window, and if I click start, after that when it tries to open the software, it's a very heavy software. When it tries to open the software, it will crash. This is common where it says it is not responding. I told, as I said before in the Windows installation, that you should wait at least 10 to 15 minutes for the first time when it loads, because it's a heavy software. Okay, it crashed. As you can see, it just closed by itself. Why? Well, that's because the NVIDIA IsaacSim requires a very specific version of the CUDA version for NVIDIA to run, and it was conflicting with my system's CUDA version. If I write NVIDIA, wait, let me just clear the terminal so you can see, NVIDIA SMI, sorry, I spelled it wrong, NVIDIA SMI. You can see my CUDA version is 13, which was also the CUDA version in my Windows machine, but in this case, for some reason, it was conflicting with this CUDA version. So the workaround for this is, so if I go slightly up, I should see the command. I will provide this command in the description of this video or in the documentation that I provide. This, what this command will do is it will ignore the version that I have installed on my system, and it will use the programmed CUDA version that comes with this installer. So if I run this now, the IsaacSim will run, and this command will run the IsaacSim software and open it up. It will not open the selector, it will just open the IsaacSim for us to use. So this I found pretty helpful for me when I was using IsaacSim for different simulations, and this command helps me to ignore the version that is on my system, because if you run your machine on the cloud, sometimes it's pretty hard to deal with dependencies, issues, or packages. Although I could change the version, but I wanted to show you that what will happen in case there is a conflict, and how it will give you the error message, and how you can basically go around it. So IsaacSim is open now, and this is where you will do your simulations. You can run example simulations, you can build your world and environment with assets provided. If I go to Window, Browse, and I go to IsaacSim Asset, at the bottom bar you will see that I have a list of assets and different types of assets. If I click on robots, there's plenty of assets here, but it will take a while to load all of these assets into the software, so you just have to wait. If I show in the background in the terminal, you will see that it's loading all of these assets in real time right now. I mean, the first time you load all of this, then the next time when you try to use the same assets or these type of materials, then it will be much faster. For the first time when you load it, you will have to wait quite a while. Now that that's done, I will close IsaacSim, so I will focus on IsaacLab now. This is pretty straightforward. We will talk about how IsaacSim works and how IsaacLab works, how they are connected to each other, and how to use them. That will be a topic of another video. Now let's move on to IsaacLab. So if in the same documentation, I will go down and I will go to IsaacLab section and go to IsaacLab documentation. And in the documentation, although it is not easy to follow, I will try to keep it as simple as possible. We will go for installation using IsaacLab pip package. Now in my Windows video, I showed my own guide. In this video, I will try to do the same. Let me just open up. Okay, so this is the guide I'm talking about. This link also directs to the same documentation, and I'm going to follow the same guide as I mentioned earlier in the Windows videos. First, what I'm going to do in my VS Code, let me clear and open folder. I created IsaacLab folder as well. This is the lab, and inside, okay, I already created the virtual environment. Let me just delete it so I can show you from the beginning. Okay, I'm going to run the Python version checker. Sorry, I wrote Python 3.11. That will definitely give me the same version. As you can see, I have an older version, but I also have installed Python 3.11, and two versions are there in my system. And so this type of version conflict will create issues when you run IsaacSim or IsaacLab and train your robot and stuff like that. So what we do, we create virtual environments. Virtual environments containerizes the packages and dependencies and isolates your project from your system-wide packages and dependencies so that it does not mess with them. The command, so this time I'm going to use the Linux command, and I'm going to copy paste. What this is going to do is create a virtual environment with Python 3.11. This is a requirement in their documentation that we use Python 3.11 for a specific version of IsaacLab or IsaacSim. So in this case I was using the version which requires Python 3.11. It is going to use this command to create the virtual environment, and I'm going to name it an env_IsaacLab. Now this will I believe the virtual environment is created. If it didn't, I'm going to enter again. Okay, this should create the virtual environment. I'm going to clear, and I'm going to refresh the folder. Yep, you can see it's there. And what I'm going to do is now activate the virtual environment. This is the command to activate the virtual environment. What it's going to do is activate the virtual environment for us so that we can work or install dependencies inside the virtual environment. So this is a binary file that runs when we run this command, and it activates our virtual environment. As you can see on the left hand side, it is green and it says the name of our virtual environment. The next step is to install or upgrade the pip package version. Pip is the Python package manager using which we can install different packages and dependencies. So before I upgrade it, I'm going to check my version. It says 22.04 running pip -- version, and it's good to upgrade it, update it always. So this is the command pip installer -- update pip. Now that it's done, I'm going to check my Python version. In this case, I don't have to write Python 3 because it's already denoting to Python 3.11. So if I just write Python version, as you can see, it's saying that okay, but Python 3.11 is installed inside my virtual environment, and my pip version, pip version 25.3, the latest one that I can have here. Next, I have to install the CUDA 12.8. This is the conflict that I showed you earlier while I had CUDA 13, and it was conflicting with CUDA 12.8 to run IsaacSim. So we had to use a special command for that. And this time we are going to install the packages and the libraries with the exact version that is required by the documentation. So let's do that. I'm going to copy the command, install, and this is going to take a while. So when it's done, I'm gonna start from there. Okay, so that is done. Our CUDA and PyTorch is installed. Let's move on to the next step. We have to install the IsaacSim and IsaacLab pip packages. This will also allow us to run IsaacSim inside this virtual environment, the one that I just showed you earlier. Sometimes it's helpful to do that, and I believe it works together with IsaacLab when we train. So when we visually want to see our training of the robots, we can use IsaacSim to see that. Let's run this, and when it's done, I'll be back. It's going to take a while. Okay, so it's done. We have installed IsaacSim as well. Now, I didn't show how to run IsaacSim inside this virtual environment in my Windows video. That's because my Windows machine was not very good it would have crashed. So let me go and get the command for that. So here we can verify the IsaacSim installation using IsaacSim command, or if we want to run it full, we can run it full here. So let me just do the full and go into the terminal, and if I now run this command, which is right now I'm inside the virtual environment, it is also going to open up the IsaacSim software. It is going to ask me to agree with the agreement or the license, and it is going to take quite a while actually. This is normal if you say IsaacSim is not responding and you have to wait, because well, it opened up for me pretty quickly, but when you open it for the first time again, it might take 10 to 15 minutes just to open it up here. So I already opened up IsaacSim through my virtual environment. As you can see, the app is fully loaded, which is inside the virtual environment in Python. And if I go to window and go to an example with robotics example, and if I go to this tab, go to policy and go, let's say this time let's load the humanoid policy. It is based on the Unit 3 H1 robot. They have trained this robot to work on flat surface based on keyboard commands. So let's load it up. Now we will have to wait for it to load. Let's see. Okay, so it didn't take much time to load this policy. As you can see, I can move around with my mouse. So right click, and if you move around it will rotate, and mouse button click, you can move up and down, and the wheel button to zoom in and out. I'm going to change the stage light to, let's see, Gray Studio, and if I press on my keyboard, so up, down, left, right arrow, as you can see it's working now. That's nice. So this is working perfect. The way we close IsaacSim or IsaacLab, let me close this, in Linux here is by pressing Ctrl and C together. Yeah, so IsaacSim is done, it's closed. Now let's move on to the steps that we were following, which is to clone the IsaacLab GitHub repository. You don't necessarily have to have GitHub installed. I believe because we already installed virtual environment, it has Git installed. So if I say git -- version, yes, Git is installed. And if I paste the command, now in Linux, copy pasting works slightly different in the terminal. You have to press Command Shift C to copy a command and Command Shift V to paste it. It will not work if you put if you press Command C and Command V. Okay, let it copy and copy it to our project. It will show up here. Okay, so we have successfully cloned the repository. If I refresh, it's here. And now we have to install the libraries and packages for IsaacLab. Let's go and copy. First we have to cd into. Now this was a mistake I did in Windows installation. I didn't move into that directory, which is IsaacLab in this case. So now that I'm inside, what I have to do, for Windows this is the command to install the libraries and packages. For Linux this is the command. So let's copy it and copy and paste it. Now terminate and let it install the packages and libraries for IsaacLab so we can run it. Okay, so the packages and the libraries are installed, and now we finally installed IsaacLab. Let's see if we are done. We can run some demo. Let's go through one of them. So let's see, this one is going to run rough animal. Okay, so let's copy this and clear. So if we want to train a robot, okay, that's called a task. We want to run a task, and we are going to use reinforcement learning policy. In this case, in this demo, we will do reinforcement learning. There's other methods and techniques. What it does is, if I go to, I believe, scripts, IsaacLab has already provided us templates and demo scripts that we can run and check. So inside reinforcement learning, in the RSL-RL algorithm or the technique, if I click on train, this is the demo code to train a policy using RSL-RL algorithm or technique on a task. And if I click on play, this is the scripts that will play after it's done training. Now how does it looks like? So I copied the command. Let's let's paste it so I can explain. So in this command, we are going to, so to run any Python script, we have to specify obviously the Python argument, and then we write the path where the code is located in, or the script. Then we define a task. So in this case, this task is called Isaac velocity rough animal CV0. Now how do I know this task actually exists? If I go to my browser and I search IsaacLab environments, and if I click on the first one, you will see they have given us a list of all the tasks that we can run, predefined tasks. We don't need to make any modification, or even if we want, we can do modification or on later stages when we work on our own projects. We can create our own custom environment and define it. But this is the list of the tasks that they have provided. If I try to look for it, look for the rough animal, let me see if I can. Okay, I couldn't do Control F for some reason, but it's here, and usually the name is denoted by this. This is the task name of a task that you want to run, and it has to be the exact same one because there's a lot of configuration that is set for this type of task. Next, what we are looking into is number of environments. How many instances of this task, or in simple way, how many instances of this robot we want to launch for training. So this is a quadruped robot that is trying to learn how to work on different rough terrains, and how many of them we want to train together. The more we train together, the faster it and the more accurately it will learn to work on this terrain. So that's this number of environments. I'm going to reduce the number of environments to 50 for the sake of showing you how the training looks like through IsaacSim. This is our IsaacLab task, and I removed this headless tag. The reason being that if I had this headless tag, I won't be able to visually see the robot learning to walk. Now if I run this, hopefully it works on the first try. Sometimes, or I think most of the times, I have issues. Yes, there was some issues here, so let's see. Why wouldn't it run? There is some extension dependencies and resolver, but I believe everything is installed properly, so this shouldn't be the case. What I will do now, I'll think there was one, there was two, and let's see. Nope, it didn't run. Okay, let's do one thing, making sure that I have the right directory or project folder. That is what I have here. What I'll do is copy the command from their official doc. Maybe I have wrote something wrong. Let's see. Okay, running IsaacLab script, generating VS Code. Now this maybe, let's go one stage back and let me go to not this one. And if I go down, making sure that I have the IsaacSim script, but it doesn't look like it's going. Let's see, maybe this will help. Okay, clear. Let's run 500. Oh, I forgot to copy P for Python. It didn't run. Okay, so I will try to fix this in the next videos, and I will tell you what the issue was and how you can fix it as well if you have similar issue. But in my opinion, in the previous runs, right, even before making this video, it was running properly with the same command, but I will look into it because I don't want to waste your time. So yeah, this is done. IsaacSim and IsaacLab installation, and next would be how you can train different policies on different robotic tasks. That is where I just got stuck when I wanted to show you the demo. But yeah, I hope you enjoyed the video. If you have any questions or if you have any suggestions and feedback, please put it in the comments down below. Thank you.